Welcome back. In this video, we're going to compute this integral between 0 and infinity of the arctangent pi x minus arctangent of x over x dx. And we're going to prove that its value is pi over 2 ln of pi. So we're going to express this one as an iterated integral. That means here, instead of integrating with respect to x, we're going to integrate with respect to y. We're going to switch the integral and find its value. But this hint is saying express as an iterated integral and solve. That means here we want to have fx dy dx. Okay, we're gonna write it in here. We integrate with respect to y first. We're gonna switch it in such a way that we integrate with respect to x first and to y second. Okay, so this is an idea, I think, to how to solve this one. But before that, we see here that we have arctangent pi x minus arctangent of x. That means our function, okay, that means if we want to express this one, we can do the following. Integral between 0 and plus infinity. So 1 over x was the one fixed here. X was fixed and y was changing. Y was changing between here. Okay, our function must be 1 over 1 plus t squared dt. And once we integrate, we're gonna integrate between x and pi x or y here. It doesn't matter, in fact, if it is x or if it's y or t. And after that, we're gonna do dx. Okay, here we see that if we can find our domain here, x is changing between 0 and plus infinity, and y is between these two functions. So our first function is f of x equals x, and the second g of x is pi x. So y in here. So y is changing between these values. Okay. Now we wanna we wanna fix y. Here we are fixing x, and here we wanna fix y, and we're gonna change x. So x is gonna change between these two functions. Here it's gonna be let's say f1 of y, which is or x. Let's say if we change it, it's gonna be x is y. So let's call this one f1 of y. That's fine. X. So it must be a function of y. And this one, if it's a function of y, it's gonna be f2 of y. So here, that means x is y over pi. Okay, so these two functions, and y is gonna change between 0 and plus infinity. Okay, so we see that. Okay, now this is our function here. Okay, so this is our y here. If we switch this one back, let me see, write it this in this manner to make sure it's clear. So let's put y here because we are doing t, we're working with y. So this one here, so I'm gonna integrate first. So I'm gonna fix y. So I'm gonna fix y between 0 and plus infinity. Here, 1 over 1 plus y squared. And I'm gonna integrate this one here, 1 over x, between my two functions f1 of y. So f1 of y is on top of f of 2. So it's going to be between y over pi and y here dx. And after that, I'm going to integrate with respect to y. So let's do that. So here, 1 over 1 plus y squared. And this one, I know that's the natural log of x between y over pi and y, and after that I'm gonna integrate with respect to y. So let's do this. Finish this one here, 1 over 1 plus y squared. This one here is going to be the natural log of y minus the natural log of y over pi. And one more step, and we're going to see what we have. So 1 over 1 plus y squared. So this is the natural log of y minus the natural log of y minus the natural log of pi, which is plus the natural log of pi dy. So here I'm going to have the natural log of pi outside. It's a constant. I'm going to integrate between 0 and plus infinity 1 over 1 plus y squared dy. Here I can find this one without doing the definition, because I know that the primitive of this one is the arctangent. So I know this area here between 0 and plus infinity is just pi over 2. Okay, so here, if we integrate, we're going to get the arctangent of pi over 2 minus arctangent of 0, which is pi over 2. So therefore, I have pi over 2, the natural log of pi. Okay, I hope that I didn't make any mistakes. If you see any errors or mistakes, please let me know. So this is pi over 2 ln of pi. Yeah, this is the one that we had to prove. Okay, so we switch the integral. That's the key idea. Okay, we switch the integral. That's how we solve it. But note here, the key is that this is our function here. This is the value of f of some value minus f of some value, and you need to see that the first value is pi x and the second one is x, and our function is 1 over 1 plus x squared, or 1 over 1 plus y squared. Okay, that's the key to solving this question. Thank you.